Hi students, in this video we will discuss inserting a node at required position. That is, insert a node at required position. That is, wherever you want to insert, you can insert. Now here let us assume that this is the first position. If you want to insert before the first node, this is the first position. This will be the second position. If you insert in between 10 and 20, if you insert 20 and 30, this will be the third position. If you insert in between 30 and 40, this will be the fourth position. And if you append, that is, if you insert at last node, this will be the fifth position in this example. Okay, we have already seen inserting at first and inserting at last. Now you can insert. In this program we will see inserting at required position, that is, wherever we want we can insert. That we will take from the user. Now in this case, first what we need to do here is, in order to insert at required position, now here let me take a function called void insert function. This insert function takes two parameters, int n as well as the int position. So you need to write here int n and int position. N is the data you want to insert, and POS is the position, that in which location you want to insert, in which position you want to insert, first, second, third, fourth, fifth. Now first we need to check whether the position is valid position or not. So if the position is less than 1, or if the position is greater than length plus 1, that is, if the position is less than 1 means before 10, then if user enters 0 or negative value, it is not possible to insert. As well as it will be possible to insert only up to length plus 1. Length means 4. The length, already we have seen a video on length. Length means number of nodes. How many nodes are there? 4. So adding at last is possible with length plus 1. Up to here it is possible. If it is less than 1 or greater than length plus 1, so simply you display one message, invalid position. Invalid position, that is, it is not possible to insert. Then after that, else means it is valid. It is valid. Then what we need to do? So here the data is already accepted, position is also available. So what we need to do here is create a new node. Create a new node, that is, allocate memory for new node. Instead of create, you can call allocate memory for node. So tell me, what is the statement we need to write for that, for allocating memory? The statement here is, so these variables we need to declare now. It must be a pointer variable. New node equal to struct node star malloc. Already we have seen earlier, size of struct node. After that, what we need to do? New node of data equal to n. New node of next equal to null. Now what we have done till now, first we have checked whether it is a valid position or not. Then if it is not a valid position, directly you display the message. If it is a valid position, then create one new node, that is, allocate memory for one new node. Now let us assume that here I want to insert a new node at, if it is the first position, I want to insert a new node at first position. Here I want to insert. Already we have seen the code for this. So let me type once again. If, inside this if, one else I am writing, inside this else part I am writing one if. If position equal to 1, that is, if user wants to insert a new node at first position. Tell me what code we need to write. If user wants to insert a node at first position, it is if position equal to 1, what happens? Previous first node will become the second node. Already we have written this code in add first. New node equal to, new node of next equal to root. New node means here this address, this 1000 will be stored in new node of next, and this address should be stored in root. So for that, what is the code? Root equal to new node. This is inserting a node at first position. Suppose, let us assume that if the position is not first, then it will be any one position. It can be either second position or third position or any other position. So for that, what we need to do, if it is not the first position, then for this we will write one else part. Here we will add one else part. That is, if position is not first, if the position is not first, this can be either second or third. This is closing one, outer else, then this is closing the function, insert function. Now if the position is not equal to first, then it can be either second or third or fourth or fifth or any other position. So here what we do here is we take two pointer variables called p and q. P equal to root of next and q equal to root. So what happens here is p will point to second node. You can take any variable names. This p and q are node type of pointers similar to new node. P and q are node type of pointers. So p equal to root of next pointing to second node. Q equal to root, that is pointing to first node. Now, so already it is clear that we are not going to insert at first position. It can be either second or third. That is why I am starting I equal to 2 from second. So what we do here is while I less than position, if I value is less than position, then we need to iterate. Now let us assume that, so here let me give some space. Let me give some space here. Now, okay, better. Let me assume that I want to insert a new node at, so first position, second, third, fourth. Fourth position I want to insert a new node. This is the new node. Let us assume that data part is 99. Next part is initially it contains null, and let us assume its address is 9000. What is the address of newly created node? 9000, and new node is pointing to this, a pointer called new node. It contains the address of newly created node. It contains the address of newly created node. It contains the address of newly created node. Now you can see here I equal to 2. So what is the position we want to insert? Fourth position. Which position? Fourth. 2 less than 4, S. So it enters into this block. Then what we need to do here is Q equal to P, then P equal to P of next. Okay. Q equal to P and P equal to P of next, then I plus plus. So Q equal to P means what happens? this address of 2000 will be stored in Q. Now Q will point to 2000. Next statement, P equal to P of next. P means 2000. 2000 of next is 3000. Now P will point to 3000. Now P will not be available here. It is pointing to 3000. After that I plus plus. Earlier it was 2. Now I plus plus will become 3. 3 less than 4, S. Again it enters. Q equal to P. Now what is the value of P? 3000. So now Q will point to 3000. P equal to P of next. Now P is 3000. 3000 of next is 4000. Now Q will come, P will come to 4000. Next I plus plus 4. 4 less than 4, false. It comes out of the loop. So now what we need to do? So now if you observe carefully, we need to insert this new node in between Q and P. So this new node of next will be P value, that is 4000, and Q of next will be new node. So after coming out of the loop, so what we need to do here is new node of next. New node of next equal to P. That is 9000 of next, it will store 4000. Then after that 3000 of next, we need to store 9000. Then 3000 means Q. Q of next equal to new node. New node is 9000. This 9000 will be stored here. Now this variable, so this address will not be there. This is inserting a node at required position. So whatever the variables we have declared in this program, so those must be used. Whatever we are using, those should be declared, like new node, P, Q are node type of pointers. I is a integer type of variable. This is inserting. Now let me show the execution part. Here the same code I have written. Insert function, if you observe, int n comma position, struct node, star new node, P comma Q, they are node type of pointers, int I. First checking the whether the position is valid or not. If the position is less than 1 or greater than length plus 1, invalid position. Else a new node will be created. Then if position equal to 1, new node of next equal to root, root equal to new node. This is inserting at first position. So other than first position, it comes to the else part. Then P equal to root of next, Q equal to root, I equal to 2, while I less the, why I equal to 2? Because it is not the first position. We are starting from second. So while I less than position, Q equal to P, P equal to P of next, I plus plus. So this process will be repeated until we reach to the right position. Then after that, Q of next equal to new node and new node of next equal to P. In any order you can write that particular statement. This is inserting one. In the main function, just call accept the data you want to insert and position where you want to insert n comma position, calling the after inserting a node. Here you write after inserting, that is after insertion you will get the output. Excuse me, after insertion you will get the output one. Now so here let me run this particular program. Directly I will run the program. Enter the data 10, 20, 30, 40, minus 1. Now you can see here the elements of linked list are 10, 20, 30, 40. Now insert function we have called. Enter the data 99. Enter the position where to insert. So I want to insert at first position. First we will see first, then fourth position I will show you. So position 1. So 99 is inserted at first position. Let us run once again. So enter the 10, 20, 30, 40. minus 1. So enter the data to insert 99. Want to insert at 4th position. Now you can see after insertion 10, 20, 30, 99, 40. So this is how to insert a node at required position. Thank you. We'll see you in next video.